All right, here we're going to take a look at the some examples for the properties of trapezoids. And let's just review real quick the four big properties that we got, right? So for any trapezoid, all right, the first property that we saw is that the same side interior angles are supplementary. All right, that, again, remember what that meant is that same side interior. In other words, this one and this one were supplementary, right? Okay, the second thing that we got, the second property that we got is that the mid segment is the average of the bases. And the formula that we're going to use, the mid segment, is the average of the bases. So base 1 plus base 2 divided by 2. All right, so that's going to be our second property. Now we got two more properties. So for isosceles trapezoid, that means the side lengths are the same, right? Not the bases, but the side lengths are the same. So I mean, one pair of same side of the same length. Well, you got two more. So the third property that we're going to take a look at is that the base angles are congruent. Here we can say that the base angles are congruent. And this one is pretty awesome. There's a lot that helps us out with that property. And the fourth property, the last one, diagonals of an isosceles trapezoid are congruent. So the diagonals of the isosceles trapezoid are congruent. All right, so these are the four big, can't fit them all in the same deal. Sorry about that. So these are the four big properties that we're going to take a look at and do a couple of examples with, okay? So the first example that we have, the first example says, find the missing angle. Find the missing angle, okay. So the missing angle that it wants us to find is this one here, the measure of angles 8. So I know, to start with, these two are going to be parallel because it's a trapezoid, right? We know that it's a trapezoid. Now, our first property that we saw, right? Same side interior angles are supplementary. In other words, this angle and this angle, same side interior. It means here's my transversal. These are on the same side, and it's in between two parallel lines. Same side interior angles are supplementary. So 98 degrees and this together have to add up to 180. So simply put, we can just say 180 minus the 98 gives us, man, I gotta borrow. I hate borrowing. It is my least favorite thing to do. So 10 minus 8 is 2, 7 minus, I gotta borrow again, sugar. 17 minus 9. All right, carry the 27. 8, good. 82. Woo. All right, so that means that this angle here is 82 degrees. And that makes sense, right? Because it's a little bit less than 90. It's a little bit less than 90. So we know that this one is acute, whereas this one's more obtuse. Okay, the next example, example 2, says solve for x. Ooh. All right, which one of the four properties is this looking at? Well, what type of trapezoid do we have? Well, here's our base. These are our bases. And it says these two side lengths are equal. So that makes this an isosceles trapezoid. And it's looking at these diagonals. So it says PS equals 17. So the distance from P to S is 17. The distance from Q to R is 4x minus 3. And what do we know about the diagonals of an isosceles trapezoid? They are congruent. In other words, the distance from P to S is equal to the distance from Q to R. In short, we could say that 17 equals 4x minus 3. So we can say 17 equals 4x minus 3. And we could solve this just like we've been doing since 5th grade, right? Add 3 plus 3. 17, 18, 20. 20 equals 4x. And finally divide by 4. So now we see that x equals 5. Was that our goal? The direction said solve for x. I now know that x equals 5. I am done. All right. It's really just that simple. So the property that we took advantage of here, the diagonals of isosceles trapezoids are congruent. In other words, they are the same. So what do I do with these two things? I set them equal to each other. It's really important to know, what are you doing with these? Are you setting them equal to each other? Or are you adding them up and letting them equal 180 degrees? And that all really, really depends on what is the property. Look at your properties first before you haul off and try and solve a problem. Make sure you're looking at the properties. All right, the next one that we have here, example number 3. Ooh, find the missing length. Here we need to find FG. FG is our missing length, so it wants to know what the mid-segment is. So which of our properties are we dealing with here? The property that says mid-segment is the average of the bases. So I know that I'm going to be using the formula m equals base 1 plus base 2 divided by 2. That is going to be the formula that we need to use. Okay, here we go. First things first, what is base 1? 26. Okay, so our mid-segment, FG is our mid-segment, is equal to base 1, which is 26, plus base 2, which is 72, divided by 2. And here we get 26 plus 72 is 98. Oh, wow, we've seen that before today. 98 divided by 2 is 49. So that means the distance from F to G is 49 units. All we did is we filled out the formula and just followed it step by step. Okay, our last and final example here, solve for x. This one's really interesting. We got to solve for x. That's right, Louis. All right, so which property are we going to use? Well, we have to use that exact same property where the mid-segment is the average of the bases, right? Where m is equal to, Louis, please don't. Hey, put that back, buddy. Hey, I need you to go to the living room, please. Base 1 plus base 2 divided by 2. Working from home, it's a joy. All right, so base 1 plus base 2 divided by 2 is our mid-segment. So I now can use the 3 values that we have here. Okay, first value, mid-segment. What is the mid-segment with this trapezoid? Well, the mid-segment is the one in the middle, so 3x. So we're going to say 3x equals base 1, so 2x minus 5, base 2, which is 33, over 2. Now here we have to solve for x. This can get a little daunting, especially for some of us who are not strong with our algebra. We're going to look at this and go, no, I'm not going to do it. I'm in my feelings. Stop getting in your feelings and figure this out. Take time to practice solving equations. It's going to show up again and again and again and again and again and again and again. I don't want to see my kids from geometry sitting in an Algebra 2 class not knowing how to solve a basic equation. So take this time now to figure this out. You know who I'm talking about. All right. Sorry, I got in my feelings. We need to start by combining like terms in the numerator here. I have a 2x, a negative 5, and a 33. The things that can combine, negative 5 and 33. Negative 5 plus 33, well, it's the same thing as saying 33 minus 5. So 32, 31, 30, 29, 28. So now I get 3x. Everything else stays the same. 2x. Negative 5 plus 33 is a positive 28, all divided by 2. Now our next step, multiply both sides by 2, because we got to get rid of that 2. So times 2 times 2, 2 times 3x is 6x equals 2x plus 28. And now we can solve for x by getting all of our variables on one side and the numbers on the other. So here we have a 2x. I'm going to subtract 2x from both sides. So minus 2x here, minus 2x here. 6x minus 2x is a positive 4x. 4x equals 28. And now, nice and easy. X equals 7. We found the value of X. Yay. You should have enough examples to help you out with the homework. If you have any questions, reach out, email, call, text, get on your Zoom, set up your own personal Zoom time.